Hi everybody, and welcome to today's webinar on MQTT, the Industrial Internet of Things, and VTScada. I'm Dave Spencer, your host today, and with me is Samer Manser.
Hello everyone.
So Samer is a developer here in our office in Bedford, Nova Scotia, Canada, same office that I'm in. And we've got Samer today to help talk a little bit about a new VTScada subscriber driver that we're bringing in for version 12. So Samer, is there anything you want to introduce yourself a little bit, or?
It's fine. I'm just a developer here, so.
Right. Okay. Yeah.
I think it's enough.
Samer did his master's. He's got a bit of a background with IoT before IoT really was a thing, and about kind of connecting devices that are sort of out in the wild, and how do you get the information? How do you connect? How do you do that? So Samer's got, they say, his background is in this, and now so he's since being a VTScada developer, amongst many other things, he was tasked with.
I made a living. I made a living of this.
There you go. Yeah.
Was tinkerer before.
So I'm just going to bring up a webinar. Let's get this slideshow going. Okay, so the MQTT client driver. Do you want to get into a little bit about the MQTT protocol? So VTScada, as we noted, it's an MQTT subscriber driver. So that's a driver that's going to be able to gather information from devices which are using MQTT as their protocol. And then we're going to end today with a little bit of a demo. Samer, I should note right off the top is that in version 12, this MQTT driver will just be part of the software package. It's not going to be a plugin that you need to add separately. It's not going to be a separately licensed component. It's just going to be part of the software.
It's like most of our drivers, it's part of the software actually.
That's right. So any of our customers in Support Plus or anything like that, when they upgrade to version 12, which they can do at no cost, they will get it for free, definitely. Right? Yeah. So anyway, so for you guys who are currently in our Support Plus, when you go to version 12, this is just part of it. So good on you. So next up. Okay, so we want to talk a little bit about the MQTT. And MQTT, I guess, is best described as a publish-subscribe transport protocol. And one of the things about that publish-subscribe is that the publish and subscribe is fully decoupled. So that's to say one device could be a publisher, doesn't have to be a subscriber, and vice versa.
And it can be both.
It can be both,
yeah.
But there's no actual cross integration of the two
Correct.
required.
Correct.
So if you are both, there's no actually meshing of those, right?
Correct.
So,
and that's why actually we're able to have the driver being a subscriber only.
Right. Yeah. Right. So MQTT is also, people generally know it as being popular as a lightweight, open, and simple protocol. And I think it's got a history originally developed for satellite communications in the oil and gas market. Is that correct?
Correct. Yeah, I think in the 90s, if I'm not mistaken.
Right. Is it IBM?
Yeah, actually the MQ, it's message queuing, telemetry transport. We didn't mention that. And the message queuing part, actually, it's a legacy from IBM. They had a line of products that was message queuing this, message queuing that. So that was part of that family, actually, the MQ family. Now there is some queuing, some message queuing inside the brokers, but that's not how it got its name, actually.
Right. Yeah.
So it's legacy basically from there. And most of people now refer to it as MQTT. Just MQ telemetry.
Yes, yeah, I heard the acronym sort of lost its original meaning because the protocol has progressed so much since its original days. So, and one thing about MQTT is that it is very much a protocol, and the actual payload, which is part of that. So the information that's really the thing that we're all looking for when we do MQTT. So MQTT is how it gets from A to B. But what we're sending is totally agnostic to the protocol. So it could be a XAML file, it could be an image, it could be a JSON string, it could be an executable or anything.
Yeah.
So yeah, and that's one of the things that actually has made MQTT more difficult as an industrial protocol, is that you don't necessarily know what you're going to get because there's so many different types of data and so many different data structures that somebody could be sending you. So it's not like Modbus in that sense where you kind of can predict what's coming in.
It is actually the transport protocol. That's why. What it guarantees that you give me certain data, no matter what it is, give me this payload, I will get it to the subscribers.
Right, yeah.
That's all what it, actually you can use it to implement your own applications.
Right.
So you will have your application protocol sitting on this transport protocol that's sitting on the TCP. By the way, probably we didn't mention, it has to go on TCP.
Right. Okay. So your TCP/IP, so your regular like Cat5 network, sort of the same type of network that you're going to be setting up to do like your internet and your home networks and that kind of thing.
Exactly.
So some of the benefits to MQTT, the big one is it's generally set up as a report by exception type protocol, in that the device is sending a message to the broker when it has a new message, and the broker is then forwarding that off to the subscribers after it's been received, more or less.
Exactly.
There's some details that we'll get into a little bit later on exactly how that's managed. But the other one is so the benefit of that is also that you've minimized traffic over a network, because you're not doing, say, a 1-second poll or a 10-minute poll or whatever that's a function of. You're just waiting for a change and then seeing that change happen. So when something's changing really quickly, you're going to get a higher bandwidth on that device. But generally speaking, it may not change very often, and then there's essentially no bandwidth.
Sure. Yeah.
So, say, other than maybe a keep alive or something.
Correct. Yeah.
So something that I should mention, Chris just pinged me, is that I didn't mention anything about the GoToWebinar console for you guys. So you guys are sitting in front of the GoToWebinar screen, but on the right of that screen, you probably have a little interface. And one of the things that I should mention in that interface is that there should be a little box that you can open up to put in questions. And if you have questions during the webinar, please just enter them in this box. We'll see them come through. We're going to try to keep the webinar to about 30 minutes today. We might go a little bit over that because we do have a lot to cover. And Samer is a very technical guy, and sometimes he can explain things in great detail, which is fantastic, but bear with us on the timing. So at the end of the webinar, then we'll go into the questions, and we're going to try to answer all the questions during the webinar. If there's one we can't, then we'll follow up with you on that when we post all of this. The webinar is being recorded, so you guys will be able to download or rewatch a copy of the recording. And also we'll load some information in with the webinar so that there's some stuff that you can get in terms of downloadable data to go with it. Okay, so moving on. So this is just a quick image of some devices that one might see. If with the Internet of Things, I mean, we're a very broad spectrum from vehicles to different types of assets to remote location tools. One of the things about MQTT brokers as well is that you may be accessing data that's more like the kind of data that would be stored on an API. So like government data, rather than getting it from the API, you may be getting that data from, say, a government broker or a broker that's actually managing data for many things. So be it if they're doing public monitoring of river levels or anything like that, then they may publish that to a broker and give you access to even just a subset of the broker. So Samer, did you want to jump onto this slide? And
yeah, this is just a very broad illustration. Should I take over or?
Sure, I'll give you, yeah, go ahead.
I'm in now, right?
Here, I will pass it to you.
That's you actually, yeah.
So just click on show my screen there, right in the middle.
Okay.
You got it, and I'll give you full control here. I'm just gonna make it full size.
So just again to repeat this, it's just very simple protocol. Say we have certain sensors that we want them to publish or to share their measurements. Now, certain applications would be interested in getting those measurements and acting upon those measurements for whatever reason. So the way to use MQTT for such purpose, the sensors would register with the MQTT broker as publishers, and all the applications interested in getting the measurements from the sensors would register or would connect with the MQTT broker as subscribers. So how does this happen? Actually, all the clients, they connect the same way, because a client can be both publisher and subscriber. But the subscribers would have to tell the MQTT broker that we are interested in this subject and this subject and this subject. And they must know a priori what are the subjects related to the measurements that will be published by the sensors. So this is a very broad architecture, but explains a lot actually. So let's say this sensor has a certain measurement, and the measurement is under the subject, and the technical term in MQTT for the subject is topic. So let's say this sensor has a certain measurement to publish, and it will publish it, say, under a certain topic. Let's say, I don't know, something like lights slash bedroom light, let's say. Now, this is sent to the MQTT broker, and the MQTT broker knows that maybe one or two clients that are interested in this lights slash bedroom lights have subscribed with the broker. When the broker receives a certain measurement under this topic, it will send it to all the clients that have subscribed to that specific topic. So again, we'll see this in a little bit more details later, but this is basically the broad operation of MQTT, as simple as that.
Right, cool, thanks.
So I give you back the...
I don't, just go to the next one there.
Okay.
Let's carry on.
So I take over this?
Sure.
Okay. So every message sent from a publisher to a subscriber. Actually, the messages are sent from a publisher to the broker, and then from the broker to the subscribers. So the publication happens then between the client and broker and client. But the QoS level is related to the publication, whether it's from client to broker or from broker to client.
Right.
And MQTT has 3 levels of quality of service, QoS. QoS 0, no guarantee that the message will be received, whether on the broker side or the subscriber side.
Right, so that's QoS level 0 basically means there's no acknowledgement. It just basically gets broadcasted out and...
Exactly. So the publishers say, when I send something under QoS 0, he will just send it to the server and doesn't know whether it gets there or not.
Right, and server and broker are sort of interchangeable. Broker is actually kind of a historic term now.
Exactly.
That's being sort of in the newer revisions of MQTT, you're hearing the broker referred to simply as server.
Correct. 3.11, so MQTT version 3.11, which is not the last one. They started using packet instead of message, and server instead of broker.
Right.
The latest, by the way, is version 5 that came out just a few months ago, I think March 2019.
Right, and I think generally the new versions of MQTT are mostly backward compatible if a device is set up for an older version. Is that correct?
I think so, yeah. I think the 3.1 and 3.11, so 3.11 is backward compatible, but I'm not sure about the 5.
Right, okay.
Yeah, I didn't dive into that well. So the QoS level 0, we say it's at most once delivery. Now QoS level 1, it's at least once. So it guarantees that the receiver, whether a broker or a subscriber, will receive the message at least once.
Right.
But it might receive it multiple times. And in such cases, if it receives that multiple times, it wouldn't know that this is an old message. It would consider it as a new message. So this affects actually the server. So if the server receives, let's say we have here a publisher, it sends something to the server or the broker. Now, the broker has to send an ACK, we call it pub ACK, to the publisher. Now, let's say for some reason the server pub ACK did not get to the client, so this was broken somewhere. The client will have to send back the measurement again to the server. But the server, if you notice on this side, what the server did, it stored the message, published it to subscribers, deleted the message, then sent back the pub ACK. So it did not keep any memory about that message, which means if the message is sent again, the same exact message with the same message ID, then that will be published again to the subscriber. So it's repeated.
Right.
That's why we call it at least once. So
right.
guaranteed it will arrive, but it might arrive multiple times.
Right.
QoS2 actually, it's guaranteed to arrive and to arrive only once. This is actually, it's simple. We're not going to go deep into this, but there's 2 ACKs that have to be sent in each way. Right. Or actually 2 messages in each way. 3 of them are ACKs. So the receiver has to ACK the receival of the measurement, so of the published message with a pub receive. Then the sender has to acknowledge the pub receive with a pub release, and at the end the pub release has to be acknowledged with a pub comp. But everybody can notice here that as soon as the pub received is sent by the server, the whatever the client sends after that can be known that it is a repetition.
Right.
And once the pub received gets to the sender, it's not going to send the message again. It's only a pub real, pub comp. That's what gets involved. So yeah, sorry, go ahead.
I was just going to say, so QoS level 2, basically you're guaranteeing that, let's say the client or the publisher to the broker, the message only goes once, but you're not necessarily limiting the bandwidth that much necessarily, because you still have the extra overhead associated with the extra ACKs.
It comes with a price. Yeah.
Right. Correct. So now, one thing that we didn't mention here is that the QoS levels, so you can define a QoS level from client to broker, or say from publisher to broker, but then you could have a different QoS level from broker to subscriber. So it's the device will define its QoS level, and then say in our case the VTScada application would also define its QoS level.
Exactly, it's asymmetric. So the QoS between the broker and the subscriber might be different than the QoS between the publisher and the broker. And this is very flexible, because as a publisher, I think my messages are the most important, so I can send them with the highest QoS, right? But the subscriber might be on the other side not that interested in this, maybe QoS 1 or QoS 0. If it gets here, I'll listen to it. If it doesn't get here, I'm not. And how does the broker decide actually on what QoS to use for the published message? It chooses actually the minimum between the 2.
Right.
So let's say the publisher sent with a QoS 2, and the subscriber for that topic has QoS 0. The broker will send whatever it receives, even if it's QoS 2, it will receive it as QoS 0, because that's what the publisher is interested in.
Right.
Sorry, that's what the subscriber is interested in.
Got it. Yeah, and in VTScada, we've already got handling generally for the receiving duplicate data.
Yes.
So it's part of our sort of internal driver structures are built on that.
We implemented the protocol as it was described in the standard. So we support QoS 2, QoS 1, and QoS 0.
Right. So QoS 1 probably is a good protocol for VTScada, generally speaking, where you're basically going to guarantee that you do receive the message, and you're not really going to be burdened by the fact that you may have received it more than once in most cases.
Correct. And there is an interesting thing actually that we implemented. If you have timestamps that come with the messages, you can use the timestamp in VTScada. So VTScada, the way we will explain it actually, it can get the measurement and the timestamp that is carried with the measurement, if there is a timestamp with that. So in the historian, the last one will show. So not all of them, right?
Right.
This is how our
Yep.
historian is.
So yeah, we're 20 minutes in, so let's power
Okay.
through.
All right. So topics, what are the topics? They're basically subjects under which the data is published and subscribed to, so received. And the topics are simply a set of, actually it's a string. It's a string, a string of multiple levels, and the separation between the levels is the forward slash, actually. There are wildcards, two wildcards used in MQTT topics, the plus and the pound. The plus is one level wildcard, and the pound is multi-level wildcard, and it has to be at the end of the topic. Before we go ahead, we have to mention that we don't support, in VTScada, we don't support wildcards, neither the plus nor the pound, for reasons that we can explain if you are interested later. But this is just good to know about the protocol.
Right.
So you can see that. This is an example, just again, very, very simple example of how MQTT works. Here we have a set of 3 clients we labeled as subscribers, just to say that their role here is just subscribers. We have a couple of clients also registered, and we labeled them, or connected, we labeled them as publishers. And you notice what the broker or the server has here. It has a list of connected clients. So these already established connections, all these subscribers, all these publishers, they have established connections with the server. So now they're listed inside the server as connected clients. Now, there are other lists that the broker keeps. These lists are, this subscriber has told the broker that it is interested in the topic S1/S2/S3, and it's interested in that with a QoS level 2. Also, it's interested, so this subscriber that has the ID sub_ABC is interested also in the topic T1, T2, T3 with QoS 2. Now, the subscriber with the ID sub-MNO is interested in the topic T1, T2, T3 with QoS 0. You can follow this. So now, let's say publisher with the ID pub123 has a message under the topic T1, T2, T3 with QoS 2 to be published. This message is sent to the broker. The broker looks up its list and say, oh, I have 2 clients, ABC, sub-ABC, sub-MNO, both of them are interested in the topic T1, T2, T3. In other words, they are subscribed to T1, T2, T3. So what does the broker do? It will publish that message to both clients, but you notice the sub-ABC client got the message with QoS 2 because it said it's interested in the topic T1, T2, T3 with QoS 2. So it subscribed with QoS 2. But sub-MNO, it subscribed with QoS 0. And that's how this works. Basically, this is more than clear explaining how MQTT behaves, actually.
Cool.
Okay. So I go ahead with the keep.
Yeah, I mean, the keep alive, I think most of the people who are probably connected into this are reasonably familiar with the keep alive,
right.
But the keep alive basically is the idea where, because MQTT is basically an RBE, report by exception, if you had a motor that was running and just didn't stop, then your broker or your subscriber wouldn't see any updates from it. The last thing sent would be that the motor's running, and it wouldn't necessarily see any change in that. Now, you can ask the publisher to repeat the data occasionally, but there's another mechanism in MQTT called the keep alive, and that's basically sort of like a heartbeat to say that I'm still here, and then the broker knows not to close that connection, and he knows that the device is still available and ready to publish in the event that it goes into a state change that deems there to be a message.
Exactly. It's a very lightweight message. It's just saying that I'm here. That's all. And it doesn't have to send it. If it sends anything, actually, if it sends anything, whether it's a publication, whether it's an acknowledgement for a publication, it doesn't have to send this heartbeat, because the broker would trigger this timeout for the keep alive every time it receives something from the client.
Yeah. And generally, the keep alive parameter is configurable in the broker.
Correct. We have it. Actually, it is part of the connection.
Oh, okay.
The very first connect message that is sent from the client, the keep alive has to be set.
Right. Okay.
Plus the last will, we'll talk about those later. But yeah, it's, and we do provide configuration for that also.
Cool.
Retained messages. This is another characteristic of MQTT, very useful actually. The retained message, when a publisher publishes a message and it sets the retained flag in that message, the broker knows that I'm going to hold to that message. And every subscriber, new subscriber that subscribes to this specific topic will get this message. Now, when is this useful? Something like a measurement that doesn't change often. For example, a door that is either closed or opened. This doesn't happen often, right? So let's say the last message that was published by the door was that the door was closed. And the next message maybe would be 12 hours from now, like the second morning. So a subscriber that comes up in the night has to wait till the morning to know what is the state of the door.
Right.
But if we do that as a retained message, the publisher will, the broker will publish that message to anyone that subscribes. So all the subscribers that come online during the night, they will receive that message saying that the door is closed. That's basically what the retained message is. The last will is a nice concept also. It's just it specifies a topic and a message that the broker will publish whenever a client is disconnected unexpectedly.
Right.
And other clients that are interested in knowing whether a certain client is connected or not, they would subscribe to the last will topic of that client.
Right.
I'm talking too fast, but
nope,
trying to finish this as fast as we can. A clean session also, the clean session concept, by the way, the last will and the clean session, these are things that the client has to specify at connection time. So when a client connects with a clean session flag set to false, it means it wants the broker to keep a history of the session state. And the session state of a client connection is simply what topics it subscribed to. And the other thing, any messages that were in flight during that disconnection time. That's all what the state is.
Right.
We have to mention here that we don't support the clean session being false in our implementation of MQTT, again, for reasons that we can discuss if you are interested in knowing. So for us, the clean session is always true. So every time you disconnect and you connect again from our client, you have to subscribe to.
Right. So we would resubscribe to the topics.
Exactly.
And then wait for that information to come in. So
Correct.
All the information that you would get is fresh information.
Exactly.
From the time you connected forward.
Exactly. If there were any messages that were in flight while we disconnected, those are lost. The broker won't keep them and keep track of them, like hacking, or if it was a retained message or anything, it won't. Right. It won't support that.
Right.
It won't maintain.
Yeah,
that.
And you can see where that would have potential to give you data with the wrong associated timestamp.
Exactly. This is the reason why we didn't want this,
right.
Because we cannot guarantee what data will arrive later. So this is more a safety net,
right.
if you want. So our driver implementation, actually, these are probably details that, if they are interested, we can talk about. But the most interesting thing, actually, or the most important thing you need to know when you are configuring MQTT and VTScada is our addressing scheme. So our addressing scheme, actually, an address in an IO tag will have 3 parts. 2 of them optional, we'll talk about, and 1 of them is required. So the 3 parts are the topic, the payload parser hint, and the indexing tray. So the topic, by now everybody knows what the topic is.
Right.
And again, we don't support wildcards in our topics. Now, the second part is the payload parser hint. Do you remember when Dave mentioned that MQTT is data agnostic? So we expect any kind of data to come. How we're going to deal with that? We provide a decoder as a plugin. So you want to send your own version of data, whatever binary, etc. You can have a decoder written in VTS that will decode that data. And this is where you specify, and you add it as a plugin to your application.
Right. So I guess to make it clear, VTScada does come with some common data type decoders built into it.
Correct. 3 types, actually. We'll talk about that.
And we'll get to that. So, and this is the addressing scheme that you're seeing here would be the address that you put into your like IO tag or whatever it is that what the data type that's associated that makes sense for that tag.
Exactly.
So, which is why putting in a wildcard doesn't really make sense, because you're not looking for a whole bunch of different things. You're really looking for, I want to get this parameter from that device.
Correct. Yeah.
So yeah, and Samer's going to show some examples as well of some of the programming on some of the parsers that we have built in.
Right.
So that you can see that, what would you say on average? There are maybe 20 lines?
Even less.
Right.
Less.
So
I saw something with binary actually in 4 or 5 lines.
Right.
And
so
the nice thing, you can take these as templates and you change them to your needs.
Right. And there is actually a really neat one that I wasn't aware of before this webinar that Samer showed me, and that was to put if your data is being sent with timestamps, is that you could actually very easily write a parser to take a timestamp data series and actually interpret that, so that you could say read an hour's worth of data in one session and then get the timestamps associated with that.
No, actually not an hour worth of data. It's with every measurement you want.
The associated timestamp.
The associated
so
timestamp.
I guess I mean just in one transaction. Or is it an individual transaction for each?
If let's say your published message contains multiple measurements, yes, we can process that.
Right.
Yeah,
so
we can process, but again,
similar to what you would do with like a DMP3 or with a SCADA pack, where you're able to do these time data pairs and in one transaction get a group. Correct. So it allows things too. If you had an event and you need to transmit high-speed data, then you could have a parser to say that in this one transaction, I'm going to get the last 5 minutes worth of data because an event occurred.
Yeah, and this is the role of the indexing trail, actually.
Right.
Now that you say that. So indexing trail, if you have a bunch of measurements that are coalesced together, say in a JSON string, you have temperature, like the example we're going to say, you have temperature, you have temperature, you have pressure, atmospheric pressure, you have humidity, you have multiple things coalesced. The payload parser in this case can be a simple JSON parser that we provide, and then the indexing trail will help say which particular part or member of that JSON object I want. And this is what we'll show.
So that's to say you could have many topics subscribed to the same IO, because that IO may give you a JSON string that has many different parameters in it.
Yeah, in one topic.
In one topic.
If you want. Exactly. So let's say this is a nice example. This is a JSON data, if you want. It's a JSON string representing certain data. So it has like 1, 2, 3, 4 members. And you see we have one timestamp for all the 4 members. Now, The second member, K1, if you notice, it is a composite JSON string. It has another JSON string inside it, etc. So it's a composite JSON string. Now let's say we are interested in this piece of data. I don't know, you can see the, yeah.
Yep.
So this data, basically, if you want to go with the JSON notation, it's what? Your data, then first member is K1, then dot K11, then dot K113, and this element here, K1 or member K113, actually it is a JSON array. So we want the second element in the JSON array. So how do we specify, if we want our IO tag to read this, how do we specify the addressing? And I forgot to mention that the topic under which this piece of JSON data is published is building/floor1/sensors.
Right.
So this would be, sorry, this is the parser. And again, I'll rewind. And somebody, either you implemented this parser or somebody implemented this parser for you. So if you look at this parser, it's very simple. It takes some data, which is this data, and it applies our JSON parse method to it. So JSON parse data, you get X. What X is now is a JSON object in VTScada.
Right.
Now, once you get this X, you return it. So now you have the whole JSON object representing all this data. So on your IO tag, how do you specify that you want this? In your IO tag, this would be the address. You want to read, or you're interested in data from this topic, the blue part, and then you specify the data parser one, because this plugin parser or decoder, if you want to call it, is called data parser one. That is part of your application. And then you have this JSON basically notation to get to the second element in the array that is in the member K113, that is in the member K11, that is in the member K1.
Right. And actually, you're showing the JSON parser. And in the case of getting data in JSON, you don't actually need the parser in this case, right? You can leave the data parser blank.
Correct.
So it would be the topic plus, and then the JSON breakdown to basically get to the parameter.
Because we implemented that for you, actually, the decoder. You're right. But this, I use this just as an illustration.
Sure.
That's true. Thanks for reminding me. And the plus, by the way, the plus separating these three parts is mandatory. This is what we use. And why we use this? Because we decided we're not gonna use the plus wildcard and the pound wildcard.
Right. So this is to say, don't put pluses in your topics. You shouldn't anyway, because it would typically imply a wildcard and therefore shouldn't be legal in your topics.
Right.
Don't use pluses in your JSON hierarchical, because it will be interpreted, it will be misinterpreted in this example.
Yeah. So we go with just some examples of decoders or parsers. So we have certain data. Again, the data here is the payload that the MQTT driver receives, and it will pass to the decoder that you specify. So this decoder, again, is a JSON parse, but you notice here what we did, we applied whatever we want. So we applied all this indexing, JSON indexing inside here. So guess what? An IO that needs to read from this doesn't need to specify that indexing tray, because it's already taken care of here. I'm gonna skip this actually to the last one just to show. This is an example of a parser that you would implement for certain binary data. And here I chose a random binary data, and I sent it just using our VTS code, actually. It is a publisher, but we did not make it public. It's just for internal purposes. So here we have an empty buffer stream. If you notice, we put in this buffer stream a character, just the character T, and then a single precision floating point, 32.25, a certain value, and then a timestamp, and say we chose this timestamp to be current time divided by 2. So it's mid-time between 1970 and now. It's an old timestamp. So this is the message actually that we sent. It's 13 bytes made of 1 character, so 1 byte, 4 bytes for the value 32.25, and the timestamp, which is an 8-byte value.
Right.
Now, this is the decoder that you would implement. You have a buffer read from the data you receive, the payload, and we know a priori, we like the data we try to read, we need to know ahead what it is. If it is JSON data, we'll show you a trick. Even if you don't know ahead what it is, if it is JSON, you can show the JSON string, then from that JSON string, you get what you need. But if the data is binary, you cannot do much about it.
Right.
You need to know what those 13 bytes are ahead, because they can be anything, right? So because I know that the first thing is a character, I save it in C. Second thing is a float, I save it in variable X. The last thing, which is 8 bytes, I save in this timestamp. Now I read the 3 parts that came in that payload. Now, to benefit from the timestamp, our API for the MQTT specified that any decoder that give a structure made of 2 things, or 2 parts, 1 part value, 1 part timestamp, then VTScada will benefit from that and will put that timestamp in our historian that it received. If you don't want to use this timestamp, we provide the timestamp from the current time when VTScada.
Yeah. And to be clear, this is sort of getting very advanced for somebody who has a very unique structure to their data that they would need to make a very custom parser for. For most users, they'll probably be getting JSON
node XML,
and so they won't have to deal with this data parser at all.
Exactly. At all. They don't need to implement it.
But if you do have something very specific or very unique, or you work in the IoT industry making products, then just know that you could make a parser for VTScada that would work with your product and would enable it to be to work with MQTT.
Yeah, and it's very simple. It's not difficult. Like that one, it's few lines, right? That parses a binary. And say you had like other measurements here, you can just add %3b and save in something else.
Right.
It's not difficult thing. Now the last thing I need to mention is a very simple parser also provided to you with a product. It's the pass-through parser or pass-through decoder. Just takes the data and spits the data out as text. This is very useful when you are receiving a JSON data or XML data, and either you made a mistake in that indexing trail, or you don't know what you are receiving in the data. You have a look at the data you receive as text, then you choose what you want out of that data, and we'll show that in the example. So we have 3 default decoders provided: the JSON DEC, so JSON DAC, XML DAC, and MQTT pass-through DAC for decoder. These 3 we can specify. The default one, JSON DAC, you don't have to specify even. But if you want to specify an XML, our XML decoder, so you don't have to write your own, you just use this as the parser hint in your address. So this is an example here. So this is the topic x1, x2, x3 plus XML DAC plus. So this will give me the whole XML string. If I want something specific from that XML string, it's this x1, x2 / x3 plus XML DAC plus. This is doc.k1.k11.k1132, for example.
Right.
For the JSON, which is the default, if I specify just the topic, it means I want the JSON decoder, the default one, to be used. Same thing here. All of these, actually, this and the plus and the plus plus and the plus JSON decoder and the plus JSON decoder plus, all of these are equivalent. It means just pass this through the JSON decoder and give me whatever the JSON decoder gives with
Right.
no indexing.
Right.
If there's indexing with the default JSON decoder, we need to use ++ than the indexing string. This means, yes, it will go through the default JSON parser, but we need to pick from that parsed JSON data, we need to pick certain values. All right, so
Demo.
The
high diving act.
Okay, so what we're gonna demo today, a VTScada application that would read MQTT data published from a Raspberry Pi, and that data actually that the Raspberry Pi gathers comes from a Ruby. I don't know how many of you know
Here,
this.
let me, I'll put the camera on here for a second. So you guys can now hopefully see Samer holding up the Ruby.
Yeah, so this is the Ruby actually. What basically the Ruby is, it speaks Bluetooth, and it's like a mini weather station plus some extra stuff. So it reports temperature, humidity, the atmospheric pressure. It also reports, it has an accelerometer. It reports its acceleration along the z-axis, the x-axis, and the y-axis actually. So the demo, what the demo will be doing, can they see that?
Yep.
Okay, how can
you can just drag that off the side there if you want.
Okay. So the Raspberry Pi would be reading from the Ruby via Bluetooth. So we have actually on the Raspberry Pi a Python code made of 3 parts. The Bluetooth reader, if you want, it reads from the Ruby. It passes that data to 2 parts that are MQTT client connected to a Mosquito broker that runs on the Raspberry Pi itself, and another MQTT client that is connected to the HiveMQ broker, which is an online broker free to use from HiveMQ. And the VTScada actually would be reading whatever published by these 2 clients, a client connected to HiveMQ and a client connected to the Mosquito broker.
Right. And you can read from both at the same time. So you could be connected in VTScada to any number of brokers.
Exactly. So the way we do it, actually, we'll have a driver connected to the Mosquito broker and another driver, so client, basically MQTT client, would be connected to the HiveMQ.
Right.
Okay.
Cool. And so you've got that connected to the Pi that you have here?
Exactly.
So
this is the Pi.
So you say you're not seeing a video of it. You are seeing the high diving act. So you're getting your money's worth now.
Yeah. So this is, it's hard to pull it here. Don't want to disconnect. And this is here. Oh, no, it's too far. Okay. Anyway, so let's go into the demo. So we got.
If you want, you can close that camera down if it's a problem for you, but it looks fine over here.
Okay. Yeah, for me, no, it's fine. I can see here, but
Good.
As long as it is clear there.
Yep.
Yeah. So we have an application already running, but I'll show you I'm gonna go to my Raspberry Pi and start that Python code. I didn't start it before because I didn't want too much data to be going through that, because HiveMQ might disconnect us if we are publishing too much. So I think we should be starting to get some data now. Okay, so just to show you that this is the data we are receiving from the Python code that it receives actually from this Ruby. So you see the Ruby publishes its acceleration along the z-axis, which is going like up, down. The temperature, it's 25 degrees Celsius now. Acceleration, this is the total acceleration, x, y, z. It's hot here.
I know, I was going to say, it's very precise, apparently.
Yeah, it is. Yeah, they're good. It's a good product, actually, the Ruby. Acceleration Y, we have the battery also. This is in millivolts. The pressure, the atmospheric pressure, I don't know what PSI is. What would this be? 1,000?
That would be in
Not PSI, that's
PA,
watt.
pascals.
Yeah, PSI. Humidity also 34% here in this room. Another thing, this is nice, like we'll probably demonstrate later. You see this bottle here? Actually, the bottle is just an indication of how this is positioned. We can use the acceleration along the z-axis to show whether this is tipped. This is fully tipped, or whether it is straight. So if I turn this straight, it should go back to the straight position.
Right, and you're reading this from the Hive broker.
This is from the Hive broker, actually.
Right. So that's going from here via Bluetooth to the Pi.
To the Pi.
The Pi is then publishing that
to the Hive
wherever Hive is.
Exactly.
And then VTScada is subscribing. So Hive then is basically sending the message to VTScada.
Exactly, and this is this is the data actually being sent by Hive to our broker. So
and I should mention a big benefit that potentially, because we haven't implemented it here, but it's something that you could, is that whole process sort of beyond the Bluetooth from here to here could be done through SSL quite easily, with only having Hive being the only server with the SSL certificate.
Correct. Yeah.
And that's a big difference to sort of an older paradigm where you're pulling devices, and if you want to connect SSL, then those devices are really your server, and the device has to have a cert. So you're either dealing with self-signed certs to encrypt your traffic, if you're doing it manually, or those devices have to be on the internet and you have to have a paid cert or use Let's Encrypt or something on those devices. And the devices oftentimes don't have the processing power to actually be an SSL host.
Correct.
So, so they say,
like
so moving it, that really can be a big paradigm shift for people, is being able to do SSL from these really lightweight devices to your SCADA system.
Right. So what you can do, actually, do you think I should go and explain each of these, how it is done, or just start fresh, like with a couple new examples?
Let's do quickly the pass-through, because I think that's pretty cool. Or are you going to show the pass-through?
So let's show here, this is to Mosquito. So as we said, we have two brokers that we are using. So the first broker actually, the first driver, we have MQTT client driver. It's connected to the Mosquito broker on the Raspberry Pi. And I'll show you, we have a TCP port. The TCP port named TCP to Mosquito, its connection. This is the Mosquito IP address.
Right, and in this case, that's a local address.
Exactly, it's a local address for this Pi. The Pi actually is acting here as an access point, Wi-Fi access point, and my computer is connected to that Wi-Fi access point. Now, the connection port for MQTT is 1883. This is the standard, unless you set up. Non-TLS. The TLS is something else. I forgot what it is. Now, in our architecture, by the way, you specify the TLS. If you want a transport layer security, you specify it in our port. So you can specify your TLS through the TCP port when you set it. So this is this is the TLS tab where you specify the TLS. We did not bother with an example of TLS because we need certificates to set certificates on the broker, so on the Mosquito, and we have to set it here. We did not bother with that, but you have that ability to secure your MQTT. You use your TLS on the TCP ports that use the
and that's
that MQTT uses.
Even if you wanted to do it locally, so you weren't going out to a third-party certificate authority to actually authorize that the certificate was properly signed.
Self-signed.
Self-signed,
I think they call them. So we set up this. Now, in our TCP port, it's better to set this disconnect delay large enough so that the port itself doesn't disconnect on you if you don't publish or you don't receive within, sorry, if you don't receive
Right.
within certain.
So I think it's, yeah, as long as that's higher than the keep alive, then you're probably okay. Would that be correct?
Correct. Exactly. You have to set it more than the keep alive. It's better. Yeah. So this is how we specify the client. So we specify which port. In other words, the port is the specification of what broker we want to connect to, because the port holds the IP of the broker we connect to. And you notice this MQTT client ID. We didn't talk about this, but every client that connects to a broker must specify, actually I shouldn't say must, there should be a unique client ID identifying that client on the broker. And with two options, either you don't specify a client ID as a client and the broker will give you one, but this is not part of the standard. So there might be a broker that does not give you a unique client ID. But the two famous ones we know about, Mosquito and Hive, they do give you a unique client ID. In our case, we did not wait for that. We generate a unique client ID for every MQTT client driver we have. And this MQTT client ID actually is guaranteed to be unique on the broker, and it's guaranteed to be unique within the application and the servers, I should say the VTScada application and the VTScada servers that are used in the application.
Right.
Because we have a distributed architecture, like our clients know about this anyway, that a copy of the driver might be running on two servers running VTScada in case there's no communication between them. This is redundancy in our distributed architecture. So the client ID we provide here, you cannot change. If you notice, it's just for your information to know the unique client ID. You can set this client ID actually, or change things in the client ID by changing the name of your client driver. And we provided a string here, a prefix string for what do you call it, branding.
Right.
If you don't want VTScada, you can change this. It's just this first part. You can change it, but the middle part is generated automatically.
Right. Cool.
The keep alive you specify here. The QoS you specify here. So this driver would provide the same QoS for all the IO tags connected to it.
Right. Okay.
So here you can specify the credentials. This is if your broker supports credentials or TLS or whatever, you can specify that right here. Yeah. The last tab here is the last will. So you can specify in the last will what topic you want your last will to be published under, and the last will message and the QoS for the last will message. And also you can specify whether you want it to be retained or not. If you want it to be retained, it means it will stay there, and everybody that is interested in knowing whether you're disconnected or not will receive that no matter when they
right.
connect.
Right. Cool.
So,
are you thinking of starting a new app?
We can start a new page here, so we don't start a new app.
Let's do a quick, take a quick moment. If you have any questions, well, Samer's getting ready to do this. Samer, you can Good. Carry on with this. Good. But if you have any questions, enter them now, because I know we're a bit over time, and I want you to have a chance to get your questions in before you have to go. So enter any questions you have, and we'll kind of pause things when there's a good opportunity. We'll go into the questions, but if you'd like to hang around, Samer's going to carry on, and he's going to sort of set up a new application and just basically show you actually setting your tags and connecting and actually drawing some MQTT connections.
Okay, so I can talk
Carry
now.
On, yeah.
Okay.
Yeah, there's no questions yet.
So good. So I want to connect to, let's say, Hive, and read that data that's being published. So first thing we do, we create an MQTT client driver. Let's call it MQTT 1 to Hive, just to know. So in the connection here, we need to create a port So a new TCP port, and let's call it TCP2 to Hive. And in the connection, I know the Hive, it's broker.hivemq.com, and the port, as we say, the standard port for MQTT is 1883. And let's give it a large disconnection delay. Just
I think that is equivalent to the default keep alive.
Yeah, so let's have it longer, say 180 maybe. That's good enough. I'm not going to use TLS. So we'll choose this TCP to Hive 2. We select it. So this would be the port that this new driver we are using will be using. And the keep alive is 120. That one was 180. We can specify the QoS to be 2. So we want all our topics are very important. We want them to come with this. Credentials I won't specify, but I will specify something here. Last will topic, I think I named it something. Let's say VTScada /disconnect. And last word message, VTScada driver 2, let's say, is disconnected. Okay, and just to make sure, let's say it's QoS2, and okay. So now we have that driver. I wanna plot. We called it MQTT1 to Hive, I think. So if we draw it, draw a COM indicator, green is everything is fine, and we want to show the stats. The stats are pretty useful, actually. It shows you any errors. I'll show you here. So the module reporting success, this is the last module that reported success was connect. This means that you connected fine. There are no errors down here, if you notice. And it's green also. It means everything so far that happened is fine. So this driver actually had established the connection with Hive. It's fine. So now we need to do what? We need to connect certain certain IO tags to receive the data from Hive. So we create, I'm gonna use the new IOs actually. So IO, and let's call it full data from Hive. And you'll see why I call it full data, and I say 2 because I might have another one.
You need the tag type there?
Yes, we need to set this to
string.
And you'll see why we set this to string. And so now comes the connection of this IO tag to the client, to the broker, how this happens. All what you need to specify here for the IO device, the last driver we created, that MQTT1 to Hive. So we select that. And then the read address. So I don't know what data I'm going to be receiving from the Hive that comes from the Raspberry Pi. Okay, but I know the topic. The topic is sensors /Ruby /R6. Okay, so look what I'm gonna specify, because I don't know that what data I'm gonna receive. I'm gonna specify the default. Sorry, not the. I mean the provided pass-through parser. What did you call it? MQTT pass-through parser. And whether I add the plus or no, it should be the same. We cannot specify the scan interval because this is not solicited data. We just wait, and when data is published, it will come to us from the broker. So we do OK. I'm gonna draw it, and I'm gonna use a string text. So let's see what we have here. If I do show stat, look, now it reports, the driver reports that the last module that reported success was the subscribe module, and it would give you what it subscribed to actually. Sensors Ruby R6 was correct. It's, am I missing something? Because I didn't receive the data yet. Probably I typed something wrong. I want to have MQTT pass.
You need plus.
This is
oh, okay, yeah.
Yeah.
Plus the MQTT pass.
And this is Ruby sensors. Let's look at those.
Sensors
Maybe
are
something. By the way, topics are case sensitive.
Yeah, it's the capital R6. I'm looking at, yeah, I'm watching it here. I've got the Hive dashboard up.
Yeah, you are able to get it, right?
Just try it with plus plus to see if you have a mistake in the MQTT pass through.
And I will get an error there. Yeah, I don't know, maybe the tag, it's that string stuff. Do you know if it will show? Actually, the other page, I'll show it on the other page. It's, yeah. This is another IO tag. It's reading from MQTT to Hive. Yeah, it is correct. Probably that, no, the plus plus won't.
Oh, it's a capital.
No indexing.
It shouldn't matter.
No, it shouldn't matter here. Why is that? Same thing, string, IO.
So anyway, I mean, this is basically what it's trying to show here is that the pass-through,
Yeah.
if you send that pass-through straight into a string, you'll see the full data structure without having to know it beforehand.
Correct. It gives all the assessors. You see, this is the error. Both of us, we couldn't see it. You see it?
Yeah.
Assessors. It's sensors. Sorry, guys.
We're both dyslexic.
Yeah. Okay. So now it should receive very soon. We should see publish RX. You see the publish RX. It means it's received. I just need to expand that string here just to show you. So the pass through is pretty useful if you're dealing with XML data or JSON data, because you will just see everything that's received in there, and you choose what you want out of that. Okay. So let's say now I want specific things. So I want a new IO tag that is a measure of temperature, for example. So new IO calculation. I should put it to analog, right, Dave?
Thank you to Dan for pointing out that the sensors was spelt wrong. And also Shannon. So I'm just seeing those notes in the questions now.
Really sorry, guys.
No, thank you guys for pointing that out.
Yeah, thank you. It worked now, though. So hopefully you won't make the same mistake. So now let's say this is the temperature IO. Here it's okay to misspell, but here, okay. So sensors, Ruby, R6, MQTT pass through. I don't want this now because I want my data to be parsed. I know this JSON, so I want the JSON decoder to parse it. So either I leave it like this or I type JSON DEC. And out of that JSON string, what do I want? I want temperature. And just looking here so that you know what I'm doing, you see the temperature element, how it comes, or temperature member. So I just put here temperature. Did I type anything wrong?
I can't see your mouse is over it.
Okay, temperature.
It looks.
Yeah, should be fine.
It looks the same as I'd spell it.
Okay, the scaling is 0 to 100, 0 to 100. It's fine. So we have that temperature. Where is it? What did I call it? temperature IO. So I'm gonna draw that. Let's use something. So let's use this. Okay. So we're drawing the temperature here. Cessners again, guys, you didn't catch that also. So sensors / UVR6 temperature.
Dan got it.
Dan caught it again. Yeah. So we got the measurement. So let's do an experiment now. You remember we said this is from Hive, right? So I already had a client connected to Hive from Hive. It's provided by Hive. I can show you later. Like if you ask how to get there, I'll show you how. But I'm gonna publish to this same topic, which is sensors RUVR6. I'm just gonna publish temperature 90. So look what happens when I publish temperature 90. You see how it jumps to 90, and you see the string I got is simply temperature 90. Now when the Raspberry Pi publishes again the RUVI data, it's this data that we are receiving under that topic.
And this is an important thing, is most brokers aren't configured to know who owns a topic.
Exactly.
So, and that's very much done on purpose, so that you could have many different sensors that are all sharing a topic, and that maybe the JSON string or something that's attached to that sensor that gives you a device ID or something to point out who that device is. Yeah. So it's a very flexible protocol, but be very cautious that unless you have good security in who can subscribe to topics and who can publish to topics, you run the risk of having somebody else get into your broker and publish false data that as if it were coming from your sensors. So, you know, it's definitely comes with MQTT, comes with a unique set of security challenges that haven't fully been sort of
correct. But there are solutions, by the way. The MQTT standard itself does not specify these, but if you look in Hive and Mosquito, they have something that's called ACL, access control lists. So in access control lists, what you can specify is this client. Actually, what you can specify is usernames. Sorry, this user will have access to this topic, or this user is denied access to this topic.
Right.
You can specify these.
So what you want to do is find out what the client ID is, and then give that client.
Actually, sorry, it's not based on the user. User. Here we specify in the credentials the username and password.
Right.
These are the ones that are used in the ACLs,
right, okay.
Not the clients themselves.
Got it.
Yeah.
So it's basically saying is you really do need to lock down who can at least publish to your topics. Correct. Because you don't want somebody maliciously sending data or even publishing out to your sensors and saying, you know what, hit the broker and turn the pump on. And if you play around with the wildcards and stuff on Mosquito, you'll see there are a lot of things out there that people have sitting on these open brokers where you can read the data in using a wildcard and just looking at the JSON files, and you could say, oh, there's so-and-so who has you know, a light switch in their living room that's being run MQTT on the Hive broker. Yeah. I can see that there's a JSON discrete value to turn that on and off, and you know, you could toggle their lights just by kind of plugging into the broker.
Exactly. If you have access to that, then
yeah. So the open broker is great for like the Hive one that they have public is good for playing around with and like getting set up and testing things, but it's not something you'd want to use commercially at all.
Correct. They provide commercial one. That's the one where you can set the ACL, etc., etc.
Yeah.
Even the online one, I think you can subscribe to and pay money, and then it will.
Right. Yeah, I think they do provide a service to sort of have a broker, or I think you can get it where you actually manage the broker yourself.
Yeah. So I don't know if.
And Hive costs money, but Mosquito is generally free. That's true.
It is free, yeah, and it's very well done, by the way. Like we've been running Mosquito on Raspberry Pi, And also on my Windows machine upstairs, actually, I didn't show you. I have.
And Mosquito is available as a node module, I believe. So it's very, very easy.
Yeah, it's very, very powerful.
If you get NPN, then you can have node, like you could have Mosquito running on a Raspberry Pi or some other server running NPM. You could have that running in just a few minutes.
Yeah, with the, by the way, with the TLS, it's very powerful with the and flexible with the TLS, and with these access control lists, actually, it's very useful.
All right, so I'm seeing a few questions come in. So yes, the question we knew was coming, actually. So I'm just going to jump over to, if you have questions, it's a great time to put them in. I'm just going to, the first one is going to actually be really easy. So Kyle asks, are there any plans to make a VTScada MQTT broker driver? And the short answer is currently there are no short-term plans to put a VTScada MQTT broker into the product. If that's something you think you need, or if there's a reason you think that VTScada is the best place for that, then please let us know. Give us the feedback, because it is you guys who really help shape where the product goes. You tell us what your needs are, and then we kind of prioritize those and build the software accordingly. But that said, Samer has prototyped both the publisher and the broker in the product.
We have in-house.
It's just that right now for version 12, we're launching with the subscriber, but the other two components of it absolutely are possible. It's just a matter of whether or not we're the right space for that right now. So like I say, we're starting off with the subscriber because that's where sort of the immediate need is. Cool. If there's any other questions, like I say, let me know, because that's the only one we have right now. I'll just give it a minute for that, and if nothing else comes in, I think we'll probably shut her down because we're 45 minutes over.
Yes.
So.
Yeah.
So going once, going twice. Oh. Okay, I think we'll end her there. So Samer, thanks very much. You did a great job explaining MQTT as well as building it into the product. So yeah, it's something that we're really excited about. We've got WEFTech coming up. So if you're going to WEFTech, please come out, see us there. I expect we may have some of these rubies and stuff floating around.
Yes. Yes, so there. Yeah.
Right, so you'll be able to play with it yourself. You can sort of see how MQTT works. You can ask us some questions about the broker on the Pi or anything else that we're running. I think I actually have an MQTT broker on my machine using the IBM's really small message broker.
Okay. Mosquito is available for Linux and for Windows, actually.
Right. Yeah, and I actually do have Mosquito on here as well. So if you want, like say, come chat with us and we'll be happy to show you MQTT in VTScada or answer any other questions. I think we'll leave it at that. Thanks very much, guys. We really appreciate you guys attending the webinar, and have a great rest of your day.
Thank you, everyone.